In this demonstration, you'll learn about working with material properties. I've selected a steady-state thermal electric conduction template and loaded the geometry for this thermal electric cooler. When I begin with a template, AIM automatically assigns a material to my geometry. In this simulation, the default material assignment is structural steel. When I select this material drop-down, I can see the default materials listed from the internal materials library. These favorites are annotated with a star. This symbol indicates a material already used in this study, in this case, the structural steel assignment we're viewing. Because I'm defining materials for a cooler consisting of 2 copper plates, a semiconductor pellet, and 2 semiconductors, I want to change the material to copper for the copper plate and pellet, and then customize it with an additional material property. Using the body selection filter, I select the copper plates and the semiconductor pellet, and replace the default location. Copper isn't listed by default here, so I'll search for it. AIM provides a collection of material properties that can be used in your simulation. In this case, density, specific heat capacity, and thermal conductivity are already defined for the copper material. However, I need to add isotropic resistivity, so I'll select it for the Add Material Data menu, and enter the value. I'm done with copper, but I still need to define the material for these 2 semiconductors. I'll select this N-type semiconductor in the geometry, and then right-click to add a new material assignment. I want to use an N-type semiconductor material already defined in a library, so I select Add Library from the Material menu here and choose my library. I can now use the materials defined in this library. Now I'll search on N-type and select this material. You can see that the properties for this semiconductor material are already defined. I'm all finished assigning a material to this N-type semiconductor, but I still have to define a material assignment for this P-type. I select the semiconductor in the geometry, then right-click to add a new material assignment. I begin by entering the name P-type semiconductor. No material by this name is found, so I'll create a new material. I now need to add my material properties. First, I'll add isotropic resistivity. I now add isotropic Seebeck coefficient. Then I'll add isotropic thermal conductivity. For this specific demonstration, I am assuming constant material properties, but you can also define temperature-dependent material properties using a table. This is useful if the temperature dependencies are significant to the simulation. In this case, however, I'm going to use a constant. I want to save this material to my material library, so I select this library icon here. I'm going to choose the library where I had already saved my N-type semiconductor. This P-type semiconductor material is now saved to the selected library. So I have 3 material assignments defined: copper, N-type semiconductor, and P-type semiconductor. This concludes this demonstration of material assignments in AIM.